Good evening, everyone, and welcome you all for today's class. In our previous classes, we have discussed about laminar flow between two plates, and we have also discussed turbulence, modeling and types of turbulence, measurement of turbulence, and Hagen-Poiseuille law for flow, laminar flow through pipe. So now today we discuss turbulent flow. What are major losses and minor losses? Because when flow through pipes takes place, there will be losses. These are different types of losses. One is major loss. You can divide losses, pipe losses in turbulent flow into major categories. One is major losses. It is due to frictional resistance offered by the wall of the pipe and frictional resistance due to shear stresses between the moving layer, adjacent moving layers. When one layer move over another due to viscous drag, viscosity resistance, losses will take place. So these are losses calculated by the Darcy-Weisbach equation. So we today discuss major losses, how to calculate major losses by using Darcy-Weisbach law. So first we discuss what are major losses. Pipe losses. Pipe losses can be categorized into two main categories. One is a major losses. Number two, minor losses. So major losses are due to frictional resistance. This is a pipe and section of pipe. We have taken a section of pipe and this is a center line. This is a pipe surface. And losses, when fluid will flow through this pipe, losses will occur due to frictional resistance near the wall and due to moving layer. One layer move or another due to viscosity of fluid. These losses are taking place. So this loss we generally calculate by Darcy-Weisbach equation. So, and minor losses are due to number one, sudden expansion of pipe, sudden expansion when from low area to high area, fluid is moving from low diameter to high diameter pipe, and sudden contraction. These are two dominant minor losses. Other losses are due to obstruction during flow of the fluid through pipe. These are obstruction in terms of the bends, curves, pipe fittings. These are minor losses. And these are two major losses among minor losses. Although this comes under minor losses, but these are two major losses in minor losses. These are bends, curves. When pipe is very long, for example, pipe that are used for supply of crude oil from very long distances. These losses, minor losses, are almost insignificant compared to major losses. So in that case, we can neglect minor losses, but in case of length of the pipe is not very high. For example, 10 meter, 20 meter, 50 meter, 100 meter, up to 100 meter, the losses become significant. So needs to be calculated for calculating head loss due to frictional and obstructional losses. So first we discuss Darcy-Weisbach equation, how we find out major loss by using Darcy-Weisbach equation that was developed by Darcy-Weisbach. So next we discuss major loss, that is a Darcy-Weisbach equation. So let us make a pipe diameter, pipe length, cross section of the pipe. We take cross section of pipe and take two cross section point here, section 1, 1, 1 and 2, 2. This is a center line. Of the pipe, and length of this region is small l. That is the length that we have taken. Take a control volume of this fluid flow. Control volume. This is a control volume that we are taking. Here pressure is P1 and here pressure is P2. This is a pressure P1 and in opposite side pressure is P2. This is a pressure P2. See here. So and when fluid will flow from this side to this side, there will be shear resistance. Shear resistance is acting due to which will oppose flow of the fluid from this section 1 to section 2. According to experimental, because due to pressure force, fluid is moving forward. Because P1 is greater than P2. In that case, flow will occur from section 1 to section 2. Flow will flow from direction 1 to 2 because of the higher pressure from P2. There is a pressure force between these two sections. So what is pressure force? Pressure force is equal to pressure force equal to P1 minus P2 into area. P1 minus P2 into area. And this pressure force will be dissipated in overcoming frictional resistance. Frictional resistance when fluid will flow from this side to this side. So what are frictional resistance that fluid has to face when it is moving from this side to this side, section 1 to section 2? So frictional resistance on the basis of Darcy experimental observation, he observed on the basis of experimental observation. Darcy proposed that frictional resistance force is proportional. Frictional resistance force that fluid will face, and this frictional resistance force is due to wall friction and due to fluid friction occurring due to viscosity of the fluid. And this frictional resistance is proportional to number one, length of the pipe. Means length of, because we have chosen between two sections 1 and 2 we have chosen length L. So length of pipe means length कितना हो गया? Length of pipe. We have taken length of pipe section equal to L. Number two, perimeter of the pipe. Means what is perimeter? Because the circumferential perimeter will be like this. This is a perimeter. Because cross section is circular, so perimeter is this one. This is a perimeter. We are denoting by capital P. This is perimeter. So perimeter of the pipe. Number two, perimeter of pipe. Circumferential length of the pipe. Circumferential length of this is perimeter of pipe. Number three, V to power n. Here V is average velocity of fluid flow through pipe, and n is depends upon nature of pipe material and pipe type means for turbulent flow. So for turbulent flow, let us do the size here. So their observation number four. I think we have taken all three parameters on which frictional resistance force depends, and this frictional resistance means frictional resistance force. This force, frictional resistance force equal to is proportional to L and P perimeter and V to power n. And n equal to 2 for turbulent flow in all commercial pipes. इतने भी कमर्शियल पाइप्स जो हम यूज करते हैं पाइप फॉर ट्रांसपोर्टेशन ऑफ द फ्लूइड, क्रूड ऑयल, गैस एंड वाटर. So for that, most of the time flow is turbulent, so we take n equal to 2 for turbulent flow in all commercial pipe. So this resistance force is equal to, when we remove proportionality constant, then it will become F dash L P V square. And under steady state condition, what will happen? This force is equal to pressure force under steady state condition, because fluid is not accelerating, it is moving with constant velocity, so it is a steady state condition. So this resistance force is just equal to pressure force. So in steady state condition, N steady state condition, so pressure force P1 minus P2 into area is equal to F dash L P V square. So now P1 minus P, because we have to calculate in terms of the head loss. So that will be equal, because we are dividing with the specific weight of the water here. So that will be equal to F dash L P V square upon WA. Now we modify this because this is in terms of the head loss, because change of pressure divided by the specific weight of the fluid become head. That is equal to head loss HL, because we have taken small l, so here we take small l. That is equal to F dash L PV square upon WA. We can here write this equation F dash and L and V square, taking P, A by P here and W. So A by P is a ratio of area to perimeter, that is known as a hydraulic mean depth YP. That is equal to, we can write F dash L V square upon W into YP. A upon P equal to, A upon capital P equal to YP. Hydraulic mean depth. This is known as a hydraulic mean depth of the pipe. A upon perimeter, area upon perimeter is hydraulic mean depth of the, that you can also write as pi by 4 d square area upon pi d. That is equal to pi remove and d will be removed, so it is equal to d by 4. This hydraulic mean depth we will remove by d by 4. So this is now removing this one. So let us write, so HL, head loss, equal to P1 minus P2 upon W specific weight equal to F dash L upon YP V square upon W. Now we multiply and divide by 2G. We will do here multiply and divide this equation by 2G. So F dash into 2G upon W, L upon YP and V square upon 2G. Here we see these in bracket. This value you can see. This value V square upon 2G has dimension of HL, that is a head loss in terms of meter, and L upon YP is a dimensionless quantity. So this will become dimensionless quantity. This bracket value F dash into 2G upon W. F dash is dimensionless parameter and 2G upon this whole quantity is dimensionless, because this has dimension of HL and L upon YP is dimensionless, so this is also dimensionless. We can remove this whole parameter, including 3 parameters F dash 2G upon W in single parameter, that we can write as F, L upon YP and V square upon 2G. This is equation. Now we replace YP again by d by 4. So equation will become YP, we have taken d by hydraulic mean depth, that is equal to d by 4. So writing YP equal to d by 4, it will become 4F L upon D V square upon 2G. This is a Darcy-Weisbach equation. This is a Darcy-Weisbach equation, that is equal to HL. This is a Darcy-Weisbach equation, that is equal to HL. And 4F is a Darcy friction factor. This 4F, FD equal to 4F. It is Darcy friction factor, Darcy-Weisbach friction factor, Darcy-Weisbach friction factor, and this is Darcy-Weisbach friction factor. So F equal to FD by 4 equal to that is a 64 RE by 4. So it will become 16 upon RE. F is equal to 16 upon RE. That is known as a fanning friction factor. F is known as a fanning friction factor. That is a 1 by 4 of the Darcy friction factor. 1 by 4 of the Darcy friction factor is equal to fanning friction factor. So this equation is a very important equation for the all competitive examination, because you have to find out a frictional head loss. All engineering equation in calculation of head loss, because we have to calculate what is a head loss for particular distance. On that basis, we have to provide pumping stations, so that From one place to another place, the fluid can be transported at the constant discharge rate because we have to supply refinery crude oil and they refine this crude oil into different products. So we have to ensure rate of discharge that is reaching to the refinery for the purification and processing work. That have to maintain by providing pumping power at a different location so that adequate quantity of fluid can be supplied. For that purpose, we have to find out the head loss. What is head loss per 100 kilometer, per meter, or per 200 kilometer? On that basis, you have to provide pumping stations. That's why this is very important relationship. Darcy Weisbach equation is very important relation. Thank you very much for watching my video lecture, and I hope that you will like and subscribe and share it to your friends. Thank you very much, and have a nice day.